All right, so I hope everyone has the review sheet, chapter 6 and 7 review. So this has all the stuff that I feel like you really want to know pretty well for the exam. And again, you can print this flow chart and use that as the back of your reference sheet for exam 2. So statistically speaking, exam 2 is the test that most people struggle with. So please feel free to stop me at any time, ask me to clarify any questions that you're not sure why that's the answer. Yeah, Kahoot's being a bit pay to win right now. They're only letting 10 people on at a time now. So please just follow along and try to answer as best you can. If you would like to look at the answer key, there is the answer key for the exam 2 review on Canvas as well, so that you can check your work if there's any problems that we didn't clarify for you. So again, if you're not on this, just pretend that you are. Like, what answer would you pick? All right, so I see that for those who are on the Kahoot, we chose either mu or X bar. So really easy to mix up there because those both are means. So just making sure that we have all of our notation on our reference sheet for the exam, that we know which ones are for populations and which ones are for samples. And the ones that are for populations are also called parameters, and the ones that are for samples are also called statistics. So for this one, the population mean is mu and the sample mean is X bar. This one, we're looking for the sample standard deviation. All right, so sigma is the population standard deviation. That's the blue one. And S is our sample standard deviation. So just again, if you didn't have those planned to put on your reference sheet, those are good ones to put on there, just to make sure you get those couple points. And we had some new notation for exam 2. So do you know what P hat represents? Good. All right, so we had most people choose the correct answer with sample proportion. So remember, P is for proportion. So those of you who picked yellow and green knew that this was a proportion. Remember that the one with the hat, that's like the little kid, so that's the sample one. Let's go ahead and check out the next one. So what does P represent? Excellent. So P hat is the sample proportion and P is the population proportion. So again, just good ones to have on your reference sheet so that you know which one's which at a quick reference. What does sigma sub X bar represent? Pretty good, guys, pretty good. So if you knew that sigma was this population's standard deviation, and then knowing that sub X bar means of the sampling distribution. So this is the standard deviation of the sampling distribution. So again, more notations to make sure that you've got on your reference sheet for exam 2. And again, you can post in the chat, or you can just unmute yourself and shout out if there's anything you want me to slow down on or review back through or explain why that's the answer. What is the correct statistical notation for the mean of the sampling distribution of the sample mean? Excellent work, guys. So we're seeing that there's a lot of new notations that come between exam 1 and exam 2. Here we've got P, P hat, sigma sub x bar, mu sub x bar, all new notations that we should really have on our reference sheet to make sure we're getting those ones correctly. So since this is the mean of the sample means, and we know that mu means averages, so mu is mean. So this is the mean of the means, right? The average of the sample averages. All right, true or false? As the sample size increases, the standard deviation of the sample means decreases. As the sample size increases, the standard deviation of the sample means decreases. True or false? Pretty good, pretty good. So right, remember that our formula for the standard for the standard deviation of the sample means is the standard deviation of the population divided by the square root of the sample size. So if our sample size number is getting bigger and we're dividing by that number, then that would make this number get smaller, right? If I divide by a bigger number, my answer is a smaller number. So as the sample size increases, we end up getting that really skinny, not very spread out thing because the standard deviation gets smaller. So as sample size increases, the standard deviation of the sample means does decrease. As the sample size increases, the mean of the sample means decreases. True or false? Sorry, someone's asking for the Zoom link. It's on Canvas in announcements. Excellent work, guys. So the mean of the sample means is equal to the mean, right? We talked about that formula in class. So the average of the averages is just the true average. So changing the sample size doesn't change where the average is. The average is just in the middle. It stays consistent no matter what the sample size is. All right. And once again, just feel free to stop me if you feel like you could use further explanation on anything. Suppose a normally distributed variable has a mean of d. Which of the following is true? All right, so about half of the respondents got the correct answer. So if something is the mean, then that should be where our center is, okay? So if something is our mean, that's where our center should be. Can anyone tell me what is the area under the curve? Oh, got something in the chat. Correct, Avalon. It is 1. The area under the curve, no matter what, is always 1. The curve is centered on, no, that's for standard deviation, right? The spread of the curve is determined by what? Who knows what the spread of the curve is determined by? What's that?
Standard deviation?
Correct, the standard deviation. Good, so the mean chooses the center and the standard deviation chooses the spread. The area under the curve is always 1, and that green one actually just doesn't make any sense. Okay. Just meant to look complicated. All right. Is there anyone who would like me to repeat those statements? All right. The sample size affects the length or width of a confidence interval. True or false? Correct. The sample size does affect the length or width of a confidence interval. Because when we say like 95% confidence or 99% confidence, we're basing that kind of on the empirical rule, like how many standard deviations should I go out to be this confident that I have caught all the data. And the sample size affects the width of a standard deviation. Therefore, the sample size would affect the width of the interval, because it could make it smaller if the sample size is larger or bigger if the sample size is smaller. Does the confidence level affect the length or width of the confidence interval? Ooh, rough one. Okay, so, and again, for those of you who just came in, just making sure that you're trying out, would you get this question correct on the test if we were taking the test right now? And just some ideas of what to put on your reference sheet for the exam. All right, so the confidence level, if I say like 99% confidence, that would make the interval wider, right? Or if I said 95% confidence, that would make it smaller. So the more confident I am, the wider the interval. So I'm more confident that I'm going to catch the correct answer. So confidence level does affect the width. The more confident I am, the higher the number of the confidence level, the wider my confidence interval will be. Which of the following is the example of a point estimate for a population mean? All right, so this is pretty good. So looking at this one here, if you grabbed like mu equals 10, for example, then you were seeing the word population mean and you were going, oh, mu is population mean, and you would be correct on that, but it's not asking for the population mean, it's asking for the point estimate of the population mean. That's really tricky there, right? They're trying to trick you. So you want to look for that word point estimate. The point estimate is the sample version. It's our best guess at the true value. So X bar equals 10 is our point estimate of the population mean. True or false? The sample mean affects the length or width of a confidence interval. Pretty good, pretty good. All right. So thinking about a confidence interval here, our width is determined by our z-score, which is from our confidence level, which is then multiplied by the standard deviation divided by the square root of the sample size. So the three things that can affect the width of an interval are confidence level, sample size. Sorry, it's kind of hard to write on this. Try this. And standard deviation. The mean, or if we're doing a proportions, the sample proportion is just going to affect where the center exists, like what number the center is. The width is going to be determined by these three things: the confidence level, the sample size, and the standard deviation. A poll shows that 71% of people watch football. How many people should we poll to get a 2% margin of error with 95% confidence? Notice I gave a bunch of time on this, so try to see if you can identify how you would solve this problem and what would the answer be. All right, pretty good, pretty good. So we know that this one is asking for how many people should we sample, should we poll? So this is n equals, and then hopefully we'll have this on our reference sheet, p hat times 1 minus p hat. Oh, come on, pen, you can do it. Times a z-score over our margin of error squared, which in this case, we're given 71%. So 0.71 times 1 minus 0.71. And does anyone have that that z-score for 95%? 1.65 in the chat. Yeah, I'm recording it. 1.96. Thank you. Yeah, so make sure that you've got those z-scores ready to reference. Over our margin of error is 2%. And then don't forget to square it. So if you didn't square it, you probably got one of these two answers. So pulling up my calculator here.
I had a question.
Yes, what you got?
So you said that the z-scores on the exam are only going to be 90, 95, and 99.
Yes.
Okay, so we don't need to, or how would you find the z-score again?
So how would you find the z-score? So if I needed to find it and it wasn't available on here, like I think on the homework, they have some weird ones like 88% or something. So I would do inv norm. Come on, inv norm. And then I want alpha divided by 2. That's why the z thing here has z sub alpha divided by 2. So if we have 95% as our confidence level, then the rest of the 100% is our alpha. So 5% would be our alpha because 95% plus 5% is 100%. So 5% alpha divided by 2, half of 5% would be 2.5%. So I'm going to put that. And then we're looking for a z-score. So I put my average as 0 and my standard deviation as 1. And if I run that, it should give me this number here, 1.96.
Okay, thank you.
Great question. All right, and then I'm going to do divided by 0.02 as my margin of error and squared. And I got, come on, pen. There, 1977.46. Okay, but for this kind of problem, and only this kind of problem where we're finding n, we're going to just go ahead and round up. So this is going to be 1978. Leave that on the screen for one more second in case anyone needs to look. Any other pieces I can clarify here? All right. If the researchers wanted to make the confidence interval more precise, which of the following could they have done? So if you said yellow or blue, you were correct. So we go back. Should I go back? Yeah, let me go back to that slide. So we talked about this in the last chapter. So if we want precision or if we want more accuracy are the two trade-offs that we can choose from. Those are the questions that might show up on the exam. So, here we go. Precision versus accuracy. So if I want to be accurate, I'm talking about how correct I am, how likely I am to have the correct answer inside my interval somewhere. So the wider I make my interval, the more accurate I am. So if I increase the confidence level, that makes the interval wider. If I increase the sample size, that always makes me more accurate. So increasing sample size is just always good. If I want more precision, that means that I'll have less margin of error. So I'm trying to make that margin of error small. So that would be decreasing my confidence level. Actually gives me more precision. All right, anything I can clarify on this part? Okie dokie, heading back to the Kahoot here. So if the question asks, what can you do to be more precise? Then there's two correct answers. There's increasing the sample size, because that's just always good. And in the case of precision, reducing the confidence level. If it was asking for accuracy instead of precision, then we would pick green. All right, construct a 95% confidence interval for the mean price of TVs. So we're going to go to stat, edit, and we're going to put this list into our calculator in list 1. Come on, type it. 1399. 1599. All right. So once I've got them input, I go to stat, I go over to tests, and we're looking at a mean confidence level. So I want a T interval. And I'm going to go off data because I have all my data in list 1 here. I want a confidence level of 95%, and I'm just going to hit calculate. And there we go. I must have put something in wrong. So if that happens on a multiple choice,
the third number.
On the third one. Yeah, 697. See if that's it. So yeah, so if you're doing this on the test and you're like, oh my gosh, I got this answer and it's none of the multiple choice options, that's definitely the time to double check your inputs. There we go, 856.9 and 1168.9. And that would be my answer. So there are some multiple choice questions on the exam like this. So you don't have to show all of your work for those ones. You can, if you wanted to talk to me about points after the exam, but that's how we would do it for if we're given the data versus if we're given the mean and the standard deviation. All right, find the margin of error for this confidence interval. Three, two, one. All right. So looking at this interval here, if I want the margin of error, it's half of the distance between the top and the bottom, right? Because if we make that bar with a point estimate in the middle, and our error is the distance from the point estimate to the top or the point estimate to the bottom. So I'm going to say, okay, so if I've got 1168.9 as my top minus the bottom, 856.9, that's two margin of errors. So be careful because there's that's one of the answers you could pick and that's a wrong answer. So that's two margin of errors. That's all the way from the top to the bottom. So I'm going to divide it by 2 and there we go. That's my margin of error. Oh, good. So someone asked, how can we tell the difference between a T and a Z interval? So on the exam, it's just always going to be T interval. So don't worry about that. On the exam, it's T interval. In real life, the difference between a T interval and a Z interval is if you know the population standard deviation. If you know the population standard deviation, we can do a Z interval. If we don't know the population standard deviation, we have to use a student T distribution. So that would be a T interval. And that's the one that happens most often in real life is we don't know what the population standard deviation is, which is why on the exam, we're only doing T intervals. What is the point estimate for these TVs? So we have our margin of error. We have our top and our bottom. What's the point estimate? All right, pretty good, guys. So we had some choices here, right? We knew what the top and the bottom was. We knew what the error was. So we could like take the bottom of the interval and add the error to find the middle, or we could take the top and subtract the error to find the middle, or we could find the middle number of these two numbers by adding them together and then dividing them by 2, right? That'd give me the average, the number in the middle. So there's a couple different ways you could correctly find this value. Any of them work. Feel free to pick your favorite. What variable is being studied in this situation? The average weight for American short-haired cats is 9.1 pounds with a standard deviation of 2.3 pounds. Your American short-hair has a z-score of 3 for its weight. What is the variable? All right. Okay. So I'm glad to see that a couple people got the correct answer. And I'm actually really glad to see that some people chose that wrong answer, because this is the one that we see people choose a lot, because they knew that the variable was weight of American short-haired cats, but the problem's asking about averages. The thing is, if it says average, that means it's a statistic, not a variable. So our variable is the weight of American short-haired cats. And real quick, off the top of your head, does anyone know if that's qualitative or quantitative? Quantitative, good. Do we know if this is continuous or discrete? Continuous, good, because it is a measurement. Weight is a measurement. And I see someone asked earlier, and I didn't catch it, how to find the point estimate again. So I'm going to go ahead and finish up the Kahoot, and then I'll go back and re-explain that one. All right, now this one's a little rough on the test, so I wanted to talk about this one. If the average weight for American short-haired cats is 9.1 pounds and a standard deviation of 2.3 pounds, and your American short-hair has a z-score of 3 for its weight, which of these statements is true? Okay, pretty tricky, pretty tricky. All right, so if we're looking at this one, and I'm thinking, my cat has a z-score. My cat has a z-score of 3. So that means a z-score is a number of standard deviations. So this is saying that it is 3 standard deviations, and it's a positive number. So 3 standard deviations above the average. Let me write that out. Standard deviations above average. Okay, so if it's 3 standard deviations above the average, then that's 9.1, our average, plus 3 standard deviations. So 2.3 plus, come on, pen, 2.3 plus 2.3. So this one can get a little tricky. A lot of people grab like 3 pounds above, but it's actually saying 3 of the standard deviations. So let's try another out real quick just to see if you're feeling good about this. What if your cat had a z-score of -2? How much would your cat weigh? So that would be 9.1 minus 2.3 minus 2.3.
4.5 pounds.
There you go. Yep, because you would be subtracting 2 standard deviations from the average. So your z-score here, so this is a tricky one on the exam. Your z-score is how many standard deviations you're adjusting from the average. So I feel like that one tricks some people up if they didn't think about it that way before. All right. Identify the correct calculator function to solve this problem. So you don't actually have to solve it, just which calculator function should you use? And this is where that flow chart might come in handy. All right, okay. So we knew it was an interval. Everyone who contributed an answer knew that this should be an interval problem because it says here, confidence interval. Good, so we knew this was either going to be T interval or it was going to be one prop Z int. So then the question is this problem about averages, in which case it would be T interval, or is this problem about proportions or percents, in which case this is one prop Z int. So those are kind of the 2 key things we need to define here. Is this talking about confidence intervals? And then is it talking about proportions or means? All right, last problem here. Identify the correct calculator function for this problem. Ooh, kind of all over the place. All right, let's take a look here. So this problem, our first thing is this talking about confidence intervals? And as I read through it, I don't see anything that says confidence level or confidence intervals. So I'm going to say that this is not T interval, and this is not one prop Z int. It has to be either inv norm or normal CDF. Okay, so then it says, what is the probability? So when I'm being given a value and being asked to find a probability, that's normal CDF. If it was the other way around, if I was being given a probability or percent and being asked to find an inches, that's when it would be inf norm. So just again, going to, let's go ahead back to the practice paper here. So at the bottom here, there is this flow chart that you can use for this kind of problem, right? So when it says, back to my pen, are you being given a percent probability and asked to find a value or z-score? Inv norm. That's not what happened here. It said no. Are you being given a value and being asked to find a percent or probability? Yeah, we were asked to find the probability that he could fit through the door. So we want normal CDF. Sorry, it's sideways. You can print that out and you can use that as the back of your cheat sheet for the exam. All right, so looking at, and someone was asking about a problem and I skipped past it before we finished. Here with the TVs, find the point estimate. Okay, so personally, I like to always draw out that little number line. It just really makes it clear to me what's going on, what they're asking for. Let's see, I had those numbers in my calculator here. So let's see here. So I've got $856.9 on this side. And on this side, I've got 1168.9. So I can figure out the margin of error by finding the distance between the middle and the ends, right? There should be two of them there. So if I subtract those numbers and divide by 2, that should tell me what half the distance is between them. So I did that earlier. I found that it was 1168.9 minus 856.9. Okay, that's the distance between them, and then in half, because the margin of error is only half of that, right? One going up and one going down. So that's error equals 156 here, and error equals 156 here. So I could do a couple different ways to figure out what this middle number is here. I could take 1168.9 and subtract 156, or I could take 856.9 and add 156. It should give me the same answers if I did it the other way. Or I could add the endpoints together and divide it by 2, which would give me the average, which would be in the middle. So all three of those should give me the same answer of 1012.9, which would be my point estimate, that number in the middle. All right, any other questions that came up during this experience that anyone would like me to quick recap over, or questions on there? Can you plug the numbers in on normal CDF for the last problem? Sure, take a look at that in case you were asked for something like that. Okay, so for number 21, everyone can see the calculator, okay, right? All right, so I would go second vars, normal CDF, and then I want, let's draw this out. So I've got this curve here. It's got a mean of 69.5 and a standard deviation of 2.4. And I'm being asked, what is the probability someone can fit through the door if the door is 72 inches. So they'd be able to fit through the door if they're in this area. If they're tall, they wouldn't be able to fit through the area, sorry, if they're taller than that. So I want the probability that they can fit through the door would be everyone shorter than the door, would be over here. So this in red here, this would be my answer. So I want to do normal CDF of negative infinity. So I'm going to do negative 99999, comma, the tallest person who'd fit through the door would be 72 inches tall. And then my average here is 69.5. My standard deviation is 2.4. And enter. All right, so if I was writing this all out on an open answer problem, I would say normal CDF, and then I could either list the information or I could put it in the parentheses just like I had it there. So lower was negative 999, upper was 72. Sorry about this pen, guys. And then my mean was 69.5. Come on. And my standard deviation was 2.4. And then that gave me the answer of the probability they could fit through the door is 0.85. I'll just go to 4 decimal places, 1, 2. It doesn't specify how many decimal places. Okay. Whew, all done with that. Any other questions that you guys would like me to look through before we call it a day? All right, so I just recommend that you guys I know there's a lot of problems on this review sheet. I wanted to give you plenty to look through. If you go through them and then the answers are on Canvas, and if you see any and you're just like, you know, I didn't have time during the class, but now I found one, just send it to me in an email and I'll see if I can give you a better explanation on it. All right, don't forget to bring a laptop and your reference sheet and your calculator to the exam on Monday. See you guys later.
I have a question.
Yeah, what you got?
Sorry, can you go over one more time when to use like normal CDF and like all of them?
Yes, let me actually see if I can pull this up a little bit better here. Got it in reviews. Here we go. Now we can look at it straight up and down. Okay. So this should, where did it go? There we go. I recommend that you print this out and use it as the back side of your reference sheet. So let's suppose that we're looking at a problem and it says, okay, take note of the important information at the start. Cool. Then does the question ask for a confidence interval? So you got to read it through carefully and determine that you don't see anything that references a confidence interval. And then it says, are you asked to find a value or a z-score? So you got to kind of read through it and it's like, okay, are they giving me a probability or a percent and asking me to find the z-score? And if you're sure that yes, then go ahead and do inv-norm. If you're not sure, you can always go ahead and read through the next one and see if that makes sense. So let's say you said no. Are you given a value? And maybe you're not sure, but then look, are you asked to find a percent or probability? That should be clear, like right at the end of the problem, right? It should say, what is the percent or what is the probability? And then you can say, okay, then I know I'm using normal CDF and I just got to figure out what values. And that's when we want to draw out that little graph and see if we can figure out what numbers it wants us to use. Did that help?
Yes.
Okay, yeah, and I recommend just print this out, use it as the backside of your cheat sheet, and then you can have this to reference during the exam.
Okay. So for question number 22, we would be using
Has a height of
22. What is the probability? So they're
So
asking for a probability. We want to use normal CDF.
Okay.
And then for part B here, it's telling us a percent. And it wants us to interpret a value. So that's when we would use inv norm, because I would put in 90% and it would tell me a number.
and put it in.
Okay.
So part A is normal CDF and part B is inv norm.
Oh,
Percent. Okay.
okay.
Thank
Thank
you.
you.
Anything else I can help with?
That's all for me.
That's all. Thank you.
Take care.
See you Monday.
Hope your back feels better. Oh.
Thank you.